Hello students, and welcome back to another geometry video. You know what to do. Pause the video, please try this problem in your notes, and then unpause it to do it with me. Is there enough information? Do we have enough information from this diagram to conclude that M is parallel to N? Explain. Is M parallel to N? What do you think? I know that this angle is 75 degrees and this one is 105. Is that enough information to tell me that M and N, are parallel? Well, this right here, this angle and this angle make a linear pair. Regardless of whether M and N are parallel, regardless of any of that, I know that linear pairs are supplementary. So this angle and this angle need to add up to 180. So 180 minus, whoops, that looks weird, minus 105 is 75, which means that this angle is 75. And hey, look at that, top right, top right. These angles are corresponding and they are congruent. And hey, if corresponding angles are congruent, then the lines are parallel. So yes, there is enough information. Lines M and N are parallel because of the corresponding angles converse. Ta-da. So yes, there is enough information because I can figure out what this angle is because they're a linear pair. Linear pairs are linear pairs regardless of parallel lines, regardless of corresponding angles or anything like that. We learned about linear pairs back in chapter 1. Before we did any of our parallel lines, corresponding angles in chapter 3. So yes, we have enough information, and yes, M and N are parallel. Beautiful! That was a good review from last lesson. Now, let's see what we have for today, shall we? Today, we are looking at section 3.5, equations of parallel and perpendicular lines. We're actually, in this section, we're kind of going to go back to algebra. We do this exact material, this exact learning target and success criteria I have in my algebra classes. We look at it in chapter 3, actually, chapter 3 of algebra too. So hopefully this looks like a review, but it feels very like a good time to do this. We're talking about parallel perpendicular lines, might as well review the equations of them, because this is important in algebra, it's important in advanced algebra trig, it is very important that you understand this. So let's review it in geometry too, shall we? So, our learning target is that you know how to identify parallel and perpendicular lines in the coordinate plane. So yesterday, or excuse me, not yesterday, in 3.1, we identified parallel and perpendicular lines, but not in the coordinate plane. When we say the coordinate plane, we're talking about the x and y axis. We're talking about on a graph how to identify parallel and perpendicular lines. So that's our learning target. How will you know if you've learned that or not? Well, you will be able to write equations of parallel and perpendicular. And if you can do that, then you know how to identify them. So let's jump in to what is hopefully a little bit of a review. We're going to talk about slopes of parallel lines and slopes of perpendicular lines. So in a coordinate plane, and that's just when we have our x and y axes, in a coordinate plane, two distinct mean different. We can't talk about the same line. We want to talk about two different lines. Two distinct non-vertical lines. Non-vertical means that they cannot be straight up and down. We want them slanty. non-vertical lines are parallel if and only if they have the same slope. So remember, this if and only if is what we call a biconditional statement. Biconditional statement, remember from chapter 2, that means that I can take the if and the then and I can switch them around and it's true. I can switch the if and the then and it will always be true. The converse and the original conditional statement are true. So if two lines are parallel, they have the same slope. And if two lines have the same slope, then they're parallel. It goes both ways. Okay, so any two vertical lines are parallel. Okay, but remember that a vertical line doesn't have a slope, so we can't talk about this for vertical lines, but any two vertical lines are parallel. Okay, so same slope. They should have the same slope. So if this is a slope of -2, this line also has a slope of -2. Okay. Now slopes of perpendicular lines. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So if I have -2 times 1/2, that is -1, right? That's -2 over 2, which is -1. So we call this the negative reciprocal of the other slope. So the negative reciprocal is take -2 and make it negative. Well, -2 is +2. And the reciprocal is when you put it in the denominator. You make a fraction and you put it in the denominator. So the negative reciprocal of -2 is +1/2. The negative reciprocal of 3 is -1/3. And I should not put an equal sign there. They are not equal. This is the negative reciprocal of 3. Okay. So two non-vertical lines are perpendicular if and only if the product of their slopes is -1. And the product of their slopes will be -1 if one is the negative reciprocal of the other. Horizontal lines are perpendicular to vertical lines. Okay, so let's jump into our first example, identifying parallel and perpendicular lines. Determine which of the lines are parallel and which of the lines are perpendicular. Well, lines being parallel and perpendicular totally depend on the slope. If the slopes are the same, they're parallel. If the slopes multiply to give us -1, then the slopes are parallel. So what we need to do is we need to find the slope of each of these lines. So I'm going to color code. And let's look at, you'll notice that the lines are labeled A, B, C, D, A, B, C, and D. So let's go through each line, A, B, C, and D, and let's calculate the slope. How do we calculate slope again? It's the change in y over the change in x. So I take y2 minus y1 over x2 minus x1. So for line A, I have these 2 points. I have -3, 2, and 0, 3. Remember, it doesn't matter which point you want to be point number 1 and which one you want to be point number 2. If this is point number 1 and this is point number 2, that means that this is x1 and y1. But it totally depends on what you want point number 1 and point number 2 to be. So, if this is point number 2, this should be x2 and y2, and this would be x1 and y1. The subscripts, this little 1 right here, we call it a subscript. The subscripts should match the point number. So if this is point number 1, this is x1. If it's point number 2, it's x2. Okay, so here we have y2 is 3 minus y1 is 2, and x2 is 0 minus x1 is negative 3. Remember that when I have minus a negative, those come together and become positive. So I have 3 minus 2 is 1 over 0 plus 3 is 3. So the slope of line A is 1/3. We're going to continue doing this for all the other lines. Line B. And let's get rid of all of our annotations here so we can see. Line B, I have these 2 points. So let's make this x1, y1, x2, y2. So we'll have negative 1 minus y1 is 0. x2 is 0 minus x1 is 2. So this gives us negative 1 over negative 2, which is positive 1/2. Okay, let's do the same thing with line C. So, line C, I have these 2 points. I have x1, y1, x2, y2. So, I'm going to use this same formula up here, y2 minus y1. y2 is negative 4 minus y1 is negative 5 over x2 is 1 minus x1 is negative 1. Now remember, when I have minus a negative, these become positive. So negative 4 plus 5 is positive 1, and 1 plus 1 is 2. So my slope is 1/2. Okay, lastly, let's look at line D. Line D has this point. It shares. Okay, this point and this point. So let's make the top one x1, y1. The bottom will be x2, y2. 0 minus 2 over negative 2 minus negative 3. We're just following this same formula. Minus a negative is a positive, which means we have negative 2 over negative 2 plus 3 is positive 1. So this gives us negative 2. Okay, now we found all the slopes. We have found all the slopes, so now we can determine which are parallel and which are perpendicular. If they have the same slope, they're parallel. If I can multiply the slopes and I get negative 1, then they are perpendicular. So, look at this. These are the same. They're both 1/2. So that means lines B and C are parallel. Now, 1/3 is not the same as any of these. 1/3 is not the same as 1/2, and it's not the same as negative 2. Now, do you notice, are any of these slopes the negative reciprocal of one another? Well, let's see. 1/2 is the negative reciprocal of negative 2. If I take negative 2 and I make it negative, I get 2. And if I put it in the bottom of the fraction, I get 1/2. So that means, and we can double check, 1/2 times negative 2 is negative 2 over 2, which is negative 1. So lines B and D are perpendicular. And lines C and D are, and let's just use that, are perpendicular. You remember, this means perpendicular. So, because these are the same, it means they're parallel, and because these have the negative reciprocal of one another, their product is negative 1, they are perpendicular. And line A is just all alone, just all by itself. It's not the same as anything else, and it's not the negative reciprocal. Okay, all right. Let's check and make sure that we were correct. Yep, 1/3, 1/2, -2. Okay, so because B and C have the same slope, B and C are parallel. Because 1/2 times -2 is -1, B and D are perpendicular, and C and D are perpendicular. Yay! We were right. Let's move on to example 3, writing an equation of a parallel line. So, write an equation of the line passing through this point that is parallel to this line. Remember, from 3.2, there is only one line going through a point that is parallel to another line. Only one line, so we don't have to worry about finding multiple. Remember that the equation of a line looks like y equals mx plus b. This is slope-intercept form. There is also point-slope form, but we are going to use slope-intercept form because it's the easiest to graph, it's the easiest to remember, and it's the most commonly used one. So we're going to use y equals mx plus b. So we're going to write our equation in this form, but we know if these lines are parallel, it means that they have to have the same slope. So my line that I'm about to write has to have the same slope as the line that they're telling me. So here, they give me the line y equals 2x minus 3. If my line is supposed to be parallel to this one, it better have the same slope. So it needs to be y equals 2x plus b. But now what is b? We're not done writing our equation of a line until we know what b is. Y and x will still be there, but we need to figure out what b is. Remember that we can solve for b by plugging in this point. I have an x and I have a y. If I plug in this point, I can figure out what b is. So y is 1 equals 2 times x is -1. So I just took y equals 1 and I put it in here. I took x equals -1 and I put it in here. Okay, plus b. Now look at this. We can solve for b. Let's solve for b. 1 equals 2 times -1 is -2 plus b. And if I add 2 to both sides, I get 3 equals b. There we go. So 3 is equal to b. And now I'm just going to put that in my original equation. So I have y equals 2x because I want the slope to be the same. That's what makes them parallel. Plus 3. Plus 3 because we solved for b. So this is the equation of the line that goes through this point and is parallel to this line. So this is our final answer. Y equals 2x plus 3. Let's check and make sure that we were correct. Using m equals 2, beautiful. Plugging in the point gets 3 for b. Y equals 2x plus 3. Woohoo! We were correct. And this is true. You can always check by graphing. If you graph the two lines and they look parallel, then awesome. If you graph them and they're crossing, you're like, wait a minute, parallel lines don't intersect. I did something wrong. But here we can see that our lines are indeed parallel. Okay. Let's move on to our last example for today, writing an equation of a perpendicular line. So now, same thing, it wants us to pass through this point, 2, 3, but now we want to be perpendicular to this line. Well, the first thing we need to do is this does not look like y equals mx plus b. They got their slope plus y. No. I need to get y by itself. Let's get y by itself. So if I take 2x plus y equals 2. To solve for y, I'm going to move the 2x over to this side, and I get y equals negative 2x plus 2. Okay, that's better. That's better, because now I can see, whoops, that the slope is negative 2. If the slope is negative 2 and I want my line to be perpendicular, I need to take the negative reciprocal of negative 2. The negative reciprocal means I make it negative, so that's positive 2, and I put it on the bottom of the fraction. So if my line is supposed to be parallel, it means I'm going to use this slope. I'm going to use slope 1/2. We can check. Negative 2 times 1/2 better be equal to negative 1. I get negative 2 over 2. Ah, yes, which is negative 1. So beautiful. My slope should be 1/2. Okay. So now I'm going to use y equals mx plus b. I know that my m, or my slope, should be 1/2. Now remember, I can plug in this point and solve for b. So I have my x and my y. I get 3 equals 1/2 x, x is 2, plus b. So 3 equals 1/2 times 2, that's just 1. Half of 2 is 1, plus b. Minus 1 from both sides, and I get 2 equals b. There you go. And now this goes back into my equation. So I get y equals 1/2 x plus 2. Ta-da! We're done. We are done. And now let's check our answer. So let's see. Negative reciprocal. Need to multiply together to be equal negative 1. So m is 1/2. Plug in the number. B is 2. So y equals 1/2 x plus 2. Woohoo-hoo-hoo. And again, you can check by graphing. Make sure that they truly are perpendicular. But yay! We are right, and we are done with that example, and we are done with our lesson for today. So, if you have any questions, within every light bulb there is a question, so if you want your light bulb moment, all you need to do is ask those questions, get them clarified. So please ask questions. Of course, these are the practice problems that you can do to practice the skills you have seen in this video. But of course, remember to do the questions that your teacher assigns. So don't necessarily do these problems. Do the ones your teacher tells you to. All right, fantastic. And as always, we will end our lesson with a launch. Today's launch comes from Martin Luther King Jr., and he says, "If I cannot do great things, I can do small things in a great way." So some of you may think, like, I can't do great things. I'm just a teacher. I can't do great things. I can't go out and solve world hunger. I can't fix the homelessness problem in Seattle. I can't do great things. But you can still, even if you can't do great things, if you don't have the resources, you don't have the time, you can do small things in a great way. You can donate to a charity that does help hunger in another country. You can give the homeless person you see on the street, you can give them food or water or clean clothes, or donate to a charity that helps homeless people. You can do small things in a great way. You can volunteer at food banks and homeless shelters and things like that. So even if you can't do these big, grandiose things, you can do small things in a very, very great way, and you can make a very big impact. It might not be the same impact, but you can still make a big impact and a very meaningful impact. So, if you can't, and I put can't because if you really want to, you can do anything, right? But if you don't have the time, you don't have the resources, you don't have the money, something like that, you can always do small things in a great way. And I encourage you to do all small things, all things big or small. I encourage you to do them in a great way. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye-bye.